Hello everyone. We are going to continue talking about circles. This time we're going to be talking about portions of circles. We're going to be talking about a portion of the circumference, and we're going to be talking about a portion of the area. Okay, so we are going to start with the arc length. Let's first review circumference. If you remember, circumference is like the perimeter of the circle, right? So what that means is that when we talk about circumference, we are actually talking about what's going, the length of the arc all around, okay? So if we extended that, okay, if this was a string and we extended it, is how long is going to be this string, okay? So these are our two formulas, okay, for the circumference of the circle. So we know that on a circle, the radius goes from the center to the circle. So if you have the radius, then your circumference is going to be 2 times pi times r. And this one is really the one that we're going to use today. But you could also work with the diameter, which is a chord that passes through the center. And it is another way of writing it. It's pi times the diameter. And that is because notice that the diameter is 2 times the radius. Okay? So having this in mind, now we're going to talk about a piece of the circumference, a portion of the circumference. So we are here on this second circle that we have shown here. And we're going to talk about this portion of the whole circumference. So the whole circumference, okay, we know is 2 times pi times r. 2 times pi times r, which in this case, we know that the radius is 12. So the circumference is 2 times pi times 12, which is 24 pi, right? But this includes all the circle around, right? But in this exercise, in this new topic that we're discussing now, we don't want to find the whole thing. We want to find a piece, a portion. Now, I want you to see that this angle here is 45. However, and we know that the whole thing, if we go around and around, that's going to be how much? 360 degrees, right? So using this piece that we have here, this angle that we have here, it is 45. And then the total is 360. So this is the portion of the circle that we are talking about. If we simplify this either by dividing the numerator and denominator by 45, or if you use your calculator, this is going to be 1/8. So what does that mean? Well, if I went ahead and I divided this, this is going to be, so we have 1, 2, 3, 4 pieces down here. 1, 2, 3, 4 pieces up here. Okay, so we have 8 equal pieces. So this, only this is 1/8 of the whole circle. So if it is 1/8 of the whole circle, then the arc is going to be 1/8 of the length of the whole arc of the circle. So it's going to be 1/8 of the circumference, which is 24 pi. Okay? So for those of you who don't feel very comfortable with the fractions, remember that this is the same as this, and then this is 24/8 pi, and then this is 3 pi, and we're talking about inches. So what does this mean? It means that this piece here, if you extended it like this, measures 3 pi inches, which is the same thing as, if you put it in the calculator, it is about 9.42 inches. So just a review, in the calculator, you would write 3 times, and then you go second, and you look for the pi, and then this is going to be 9.42. And remember, never round to the whole number unless they tell you to. Okay? So with this exercise and this explanation that I'm giving you here, I just want you to understand that when we talk about arc length, we're talking about the piece of the whole circle. And the whole circle, the length is 2 pi r. So when we start talking about our formula, okay, which is on my next slide/picture, we see that the formula is actually coming from that we were talking about. It is a piece of the whole thing. Okay, so this is the formula. So it is a piece of the whole thing, of the whole circumference. So what does that mean? X is going to be the angle. In our previous exercise, the angle was 45 degrees, right? And then it is going to be the angle is the piece, that's how you're going to define your portion, your piece of the whole thing, which is 360. So this is the portion of the whole circumference that you're going to, of your circle, okay? So if we go to this exercise and we start plugging in this information, or instead of just plugging in, let's analyze it a little bit while plugging in. So we see that the angle of the central angle here is going to be 20 degrees, right? So the portion of this arc is going to be, the portion is 20 of the 360, right? And then this is the portion of the whole circumference, and the whole circumference is 2 times pi times r, which is 3, okay? So remember that this is the same thing as over 1. So I'm going to write this. This is 20. You don't need to write all this, but if you if this helps, okay, do it like this. If not, you can do your shortcuts if you feel comfortable, okay? And then this is over 360, okay? So 20 times 2 times 3, it's 120 over 360 pi. So this is the same thing as 1/3 pi or pi thirds. So what does that mean? Well, it means that this arc, if I extended it like this, measures pi third units. We don't know what units. Okay, so we just write units. And that is the same thing as, if you put this in the calculator, as 1.05 units. In the calculator, you're going to write seconds. Then you're going to go to the key that has the pi divided by 3. Okay? So this is arc length. Okay? Now I'm going to go back up here. Okay? Because, so before we talked about arc measure, and now we're talking about arc length. Okay? I want to be... Well, not to be. I don't want you to confuse these two terms, okay? So when we talk about arc measure, we are talking about the measure of the angle in degrees, okay? We're talking about the angle, okay? So you see, we have this and this. We have two circles. These are called concentric circles. Concentric circles have the same center. Let's write it here. Concentric circles have the same, or share the same center. Okay, and you see they share center O. Okay, so this angle theta here. This angle theta here is the central angle for both of them, okay? So they both have the same arc measure, okay? Which is whatever theta is, okay? Now, when we talk about arc length, and I'm going to change to red. When we talk about arc length, we're talking about this and this, okay? If I went ahead and I extended this as a string, this is the short one, and then this is the one for the largest one, okay? And that is because the arc length depends not only on the angle, it depends also on the radius. So even though both circles have the same central angle, their arc length is different. And when we talk about arc length, we're talking about units of length, like for example, inches or centimeters or yards or miles and so on. When we talk about arc measure, we're talking about the angle, degree, okay? And in this class, we're not really going to discuss this, but there's another unit that is called radians, okay? But you don't have to worry about that for now, okay? So I'm going to continue. Well, no, I'm not going to continue. I am going to show you the next slide or picture.